welcome to the program. Let's go to today's program. So our program we will write is that we will develop a linear model, uh, and y-axis of the linear model will be stress and x-axis will be load. Let's Control C for copy it and paste for the description of the project. Write hashtag and make it as a comments. So this is the description of the project. Let's go to the project in detail. Firstly, import numpy as alias np, then import matplotlib as give it as an alias name as matplotlib. We can get to the more detail, that is pyplot matplotlib.pyplot. Within the matplotlib we will take the pyplot as plt, then take x value. Our x value will be load, and load will be the np array. Within the np array, let's write the np array. The array will be 5, 15, 22, this one. Control C and Control V. 5, 15, 22 and 28 is the load array, and the stress will be our y-axis, that is dependent variable. This array will be, let's copy it from the above and paste it, and we get the two array x and y. So let's create a matrix. A is the assemble matrix. It will be np stack. Within the np stack we will assign x, that is load, and create np once one matrix, unitary matrix, which length will be equivalent to load matrix, and we have to make the transpose of it. To make the transpose, we have to make not like this, we have to make the transpose of it. So we have the assemble matrix. Now we have to convert the stress into column matrix. So to converting it, we have to write np dot new axis. This will convert stress into column vector. Then calculate our parameter. The parameter will be np dot within bracket we'll write again np dot, and within that we'll call np linear alg and use the inverse function, and within that we have to assign np dot product of a dot t, and provide the comma and give a matrix A transpose A product, and after that outside of the first bracket, outside of the actually second bracket, assign A dot t, and lastly we have to assign comma y. So this will calculate the parameter, and slope will be np dot round our parameter value, first one index, that is 1 up to, we will take up to 3 digit. This is for slope, Control C, Control V. For intercept, for intercept, the parameter we have to take the first parameter index 1, that is second index, and our predicted stress spread. Predicted stress will be slope into our load plus intercept. This will be the stress predicted, and we have to convert stress predicted to vertical column. So NP stack, and within NP stack assign stress predicted. So now we have to calculate the error. Error will be stress minus stress predicted, and we have to calculate the square of it, and sum of square error will be NP dot sum of the error matrix, and R square value will be round up 1 minus SS E minus SST, and we have to take up to 2 value. So there is missing something, because after sum of square error we have to calculate the mean. The mean is NP dot mean. We have to take the mean of stress, and sum of square will be sum of square equal to NP dot sum of SS will be our stress minus mean value, and we have to square it. We have to calculate the square value of it, and we get the SS value, and SST value will be NP dot sum of SS. So we get the SS value and SST value and SSC, that is sum of square error and sum of square total. So we can also calculate the R, and let's print the result. Result will be, take the formatted text R square. Our R square will be R square value will get through this, and slope will be within curly braces, write the slope, and intercept will be intercept value. So we can get the slope, intercept, and R square value. Let's save it. Press Ctrl S and run it. Start debugging. Use Python debugger. Use Python, and after that run it. Let's run it. Wait for a minute. There is a little change of y, so the value here will not be the y. Actually we can change, is actually stress. Hope wait, let's check. So let's check it. Just change the y here, it will be the stress. So let's run it. Control F5. We can run it. We can see that the R square slope and intercept value are visible here. So next we have to plot. So for plotting this, say plt dot figure, we have to create a fixed size. The fixed size will be, say, our figure So let's go to the previous part, that plt dot figure size. You have to assign the figure size. Say figure size is 10 by 8. Figure size will be 10 by 8, and after that plt dot plot. We have to plot the values. Here our x-axis value will be load, and y-axis value will be stress, and give it a black color, and plt dot plot. Over it we have to plot our x value is our load, and y value will be our stress predicted. And here let's assign the color as R, that is red, and provide plt dot x level. Give the x level. Say our x level is load. X level is load, and load is given in the unit of, say unit of load is pound. Load in pound. And similarly plt dot y level. The y level is given stress will be in psi. So last command, that is plt dot show. We have to display it. So that's it about the program. You can see the program. Let's run without debugging. You can see, just wait few minutes, we can see the lines over here. We can see the lines over here. That is our predicted line, and predicted value, and our actual value is displayed over here. We can see the data over here, and the y-axis it is stress, and x-axis the load is visible, and our r square value is 1, slope is 5.7, and intercept is 65. So this is all about the program. You can see the program. Firstly we import values, then write the load and stress, and create the matrix, assemble matrix, and after creating the assemble matrix we will convert into matrix format to calculate the parameters, and then calculate predicted values for stress, calculate errors, means, and sum of square errors, sum of SST and SSE, and calculate R square, and print and plot the figure over here. And this is the figure you can see. So thank you so much for watching this video. One small correction we have to include, that the within, after B we must have to use the dot to get the dot value. Now save it and run it without debugging. So we can see that our blue values, that is our original y values, are dot, and the predicted values in the red line. So it's showing much more better. Hope you enjoy it. Thank you so much.